how it all came about was that there was a lot of grain and things grown in the villages, but the processing wasn't available anymore. The traditional way of doing it, people didn't want to do anymore. So we tried to look at how we could sort of look at the machinery that's in the market and how we could first adapt it to be suitable, meeting many different types of manufacturers and trying to, work with them on modifying their existing machinery to process millets and things. But it continually came up with shortfalls that, agree to something but wouldn't agree fully, or, didn't really want to take our ideas forward. So then we decided that the easiest thing to do was to actually just design and manufacture the machines. It's not, they're not very complex sort of things. So the stages you can see are harvesting, cleaning, dehulling, and then value addition. So our focus has been on the cleaning and the dehulling because they're the sort of major bottlenecks that were faced in, promoting millets and things. And so this was the first machine that we sort of came up with. It's simply a grading machine that grades the material by size, but it's a little bit different to anything else that's in the market in that it's designed to overcome all the issues that we found in the existing machinery that is currently in the market. So normally if you have a multi-deck grading machine, either it will have some very complex rubber ball or brushes or something to clean the screens, or it'll be contained within a box and you have no access to cleaning and things like that. So we made it so it was accessible to clean the screens. Generally, a multi-deck will have staggered screens, so each screen is at a different size, stepped, if you like, so nothing is interchangeable, which means that if you want to do multiple processes or different commodities, you need a huge inventory of screens. So we designed it in a way that every screen is the same size, so it's interchangeable according to commodity. You can use the lower screen in the top or vice versa. So you need a much lower requirement of inventory to do multiple processes. Then maintenance on existing machines, you have belts, you have pulleys, you have bushes and all the little other technical things that require continual maintenance and are basically points of fatigue and failure that can make a machine defunct, and particularly if it's in a remote and rural area and things like that. So to overcome that, we have removed all of that and used the gearbox, a direct drive to the machine. And the actual agitation is something similar to a cradle, where it's actually hanging on a fiber reinforced polymer strip, so you don't have any wear and tear or maintenance issues or anything like that. So it's extremely low maintenance. It can run on AC 3-phase, AC single phase, and DC solar. Half horsepower motor, 0.5 HP. So very little power requirement and things. It's mobile, so you can actually take it where you want, or you can move it out of the way. You can use it for different processes and things. So yeah, this was the first machine that sort of come off the thing. So here using it in the village and things. No? So it can be used to clean the grain straight after harvest. So the farmer actually gets a better return. And if it's an FPO or something that has a secondary processing or something, then you know, like a self-help group or somebody who's another entrepreneur who's taking the product, then you know, it's good quality grain that requires very little cleaning post. So this, I was going to show a video, but how do I do that? So this is basically the machine in operation. So you can see that it's fairly simple. It's designed to be ergonomic for women who are the main user. And you know, it can be cleaned whilst the whole process is running. So there's no downtime. The motor's durable enough to run continually morning to night. You can run a whole, you know, process and things. And the output is, you know, fairly decent. Average with the millets, you can get about 1 ton per hour of fairly well clean grain with 5 different outputs. So one of the main issues is this large and coarse material that comes from freshly threshed material and things. So we've sort of incorporated this additional screen on the hopper that, you know, removes the coarse material and things very quickly. It also prevents any blockage from the flow gate on the hopper, so you can have a more accurate flow. Then I have to go back again. Sorry.
Next one.
We can go back to the PowerPoint.
Okay.
Is it still there? Okay, we have to open it. So our second machine that we're now, this is just, first prototype is finished. This is a hulling machine, so basically it removes the husk of the grain and produces a rice through centrifugal force against a impact surface. So we've optimized this specifically for millets. So if you run paddy through it, it's not, you know, as good as some of the other hulling machines that you may get for paddy. But it's about the most efficient output for millets of any of the machines that are currently in the market. And we've divided the aspiration and the hulling as 2 separate modular components. So it allows for more ergonomic setup of the machinery, and it's fairly lightweight and things, so it's movable and things if you need to remove it from a process and then, you know, bring it back into a process line or something. So it enables you to lift the aspiration high enough so if you want to do secondary grading and things like that. So again, any of the hulling machines that are in the market currently require at least half a day downtime to disassemble them for cleaning and for changeover of a grain. So if you want to go from one millet to another, you would have to disassemble the machine, clean it thoroughly and things. Our machine you can do within 10 minutes. So what it means is that you have much less likely residual infestation within the machine because it's accessible. You know, if it's difficult to disassemble and difficult to repair, then the operator tends to skip the process and things like that. So this sort of enables a more, hopefully you get a better output, you know, less likely to get residual material and infestation in your process. because some of the material will be broken. So where the insects tend to be prone is in the broken and the things, which are secondary process. The main focus is on the rice output. So like that. Again, this uses low-powered, it's 1 horsepower for the impeller and 1 horsepower for the huller and 1 for the aspirator. At present, we've only run it on 3-phase, but we will be working on DC solar and also AC single-phase models as well. It's all fabricated with local materials, so a lot of the other machines in the market that are similar have imported components and things like that, which are also not as durable as this. We've tried against the imported models, and our components are actually more long-lasting and more economical. So this is basically, set up simple, so you can have the hopper quite low down, so it's easy for loading, but you can have the aspirator high enough to get a good grain collection and with, regular vessels and things like that. So some of the hiccups that we had as a startup was that iSeed's support came in timely, but other parties is still pending. So in order to keep the whole process going, we had to sort of beg, borrow and steal, if you like, from anywhere else we could find to keep things going. But if we've produced a product that we managed to do with what we had, but maybe it could have been better, but we can see in future how to improve and things. One of the other problems or issues that we had in our location is enticing skilled people to come and stay in the rural area or in a remoter area and work with us and join our team and things like that. And also finding locally skilled people who would, join the team. And then just sort of learning the whole process of a business. I mean, never, having any experience whatsoever in business, then trying to, manage teams, do accounting, reporting and outreach, and along with, developing continually new designs, new models and things like that. So it's been an interesting journey. So vision, I suppose, is to, work on these technologies and things and creates a sort of sustainable farming futures and things like that. So if anybody's interested, we're welcome you. We're actually planning to move our setup from Kadri to Andhra Pradesh in Srikakulam district. So we'll see how that all pans out. Some of our partners who have supported our, work and concepts and our journey, and our contacts. So.
What would be the price of, let's say, the first one?
So, at the moment, it's about 65,000 for the grader, plus GST and things. But our plan now is to actually create a package of the 3 machines as a, as a package, if you like. The 3 of them are more or less mobile. So, the grader can be shifted from pre-cleaning to post-hulling purpose and things like that. So you don't need fixed machinery. Even the destoner is actually mobile. You don't even need to mount any foundation or anything. It'll run without. So it means that you can in a small workspace, you can actually do the whole process from pre-cleaning to, right up to marketable product, market rice and rawas and things like that. But actually, the actual price of the package we also haven't worked out. This is just the first stage. Now the huller, like I say, is just coming under its first prototype. So the next phase will be that we'll make a couple of them as per our design and put it out into the field and get some feedback and things from users, and then we'll actually put a whole package out into the field and just get some feedback and things, and then look at how to take it all forward. No, Dinesh and I are partners. There are 3 of us as part of the LLP.
So Dinesh's earlier machine was a grader. This is the huller.
As you had mentioned that the grader, right, it runs on solar DC as well. So the other ones also can be fully decentralized?
We will eventually. I mean, they can be run AC with inverter and things, but we will actually also work with DC eventually.
Okay.
That's the plan, is that it'll all actually be solar.
So it can be completely DRE?
Completely, yeah, DC.
Can you think of making it solar? Can you think of making it solar at some point of time?
Yeah, Celco is I
That's
think
what
pushing them.
We're working on it now as a second phase. One full line will be solar.
So Peter, quick question. How long did it take, or how many prototypes did it take for the first machine? And how has the demand been so far?
So
Wait, you can take one more question here.
the grader actually took quite amount of time because we partnered with a design institute or a design company. So they built the design, then we tested it, and then went back and forth. We actually made about, we're now to our 7th model, if you like. So as we've started to create the process line, so all of our machines are done a little bit different to how regular fabrication, in that we've used some fairly high-tech software to sort of create it all and do the analysis, but also that all the machines are done with jigs and templates and everything. So every component is interchangeable. A normal fabrication of any of the machines in the market currently are like a Rolls Royce. From the very ground up, everything is exactly to that machine. You cannot interchange a single component. A manufacturer will insist that you send the entire machine back to the workshop for any slight repair because they don't have an interchangeable piece. They can't ensure that that component will fit their machine even though they've made it. So with our machines, everything is done with jigs and everything, so we're all consistently, everything's interchangeable. You can do component-wise fabrication and things. And so actually, one of our goals is to actually not have some huge factory that pumps out these machines and ships them around the country, but rather that we create a package with all the jigs and fixtures and send the package to Rajasthan. Let some entrepreneur set up a unit there and sell them locally. Because there's a huge footprint on just transportation and expense also. No? We recently sent 4 machines to Bihar. It costs nearly half as much for the shipping or the transport and the packaging as what it costs for the machines. And some of the machines got damaged in the transport also. So, I mean, you know, how do we deal with that? I can't send someone to Rajasthan, to Bihar to repair them and things, no? And it's not, logistically possible to send the machine back and repair it and then send it again. So all of these things are issues, no? And I mean, that's a fairly simple machine. So if we had, the package in jig form, it's not an expensive, it's not you don't need really high-tech equipment. You don't need laser cutting machines or anything like that. It's a welding machine, a cutting machine, a grinder, and a few very simple tools. You can make the machines yourself, and employ people locally. So that's the overall sort of goal. We'll see how long it takes to get there.
I think yesterday or day before day, you were talking about fortune at the bottom of the pyramid. See, India produces something like more than 200 million tons of grains, food grains for processing. And all that we have been able to in the last 70 years of, or more than 70 years of independence, is to more and more produce centralized systems of food processing and then aggregation and all that. So given that there is a lot of scope for creating interlinked decentralized economies in around the food and staple food consumption, like production, consumption and all, I think that is the direction in which we have thought. And then from our experience, there are only a handful of machines that are required and that need to be worked on, and then maybe some design improvements done. So then you can come scale down in terms of the power and also the way they have been done, maintenance and all. So that can make a huge difference in the rural areas in the way currently this the food processing, like it's basically primary processing, I should say, that is being carried out. So and it's in the order of thousands of billions of rupees actually, if we talk about. So the scope is huge, and the amount of money that can go to the communities is also not a small amount, because it's almost like if you are spending 1 rupee of the grain, the other processed grain will be about 2 rupee or more than that. So it is almost like double the price. But who controls, who manages the whole thing? And as we are talking about access, affordability, and then a couple of other things that we were discussing, I think from this perspective, this point of view, the farming future is about the production, the farming aspect, as well as the complementary, that whole ecosystem around the production as well as the post-production thing, around which we all have to think and then look on developing these kind of small technological solutions and advancements. And like what Rahul was saying about like who is the customer, and this, the customers are all around us and in the villages, but we now produce something, send out, and again look out to get back and all. Probably the way we have to redefine and then reorganize these interlinkages, and then the movement of the resources and the money, or the whole finance could help. Look at what you were talking about, the youth, engaging the youth and then giving them back an opportunity in which they could be able to feel that they are better doing, rather than run a cab or something else. And so thank you very much.